Good afternoon, class. We are looking at pre-calculus practice test number 3, module 3, covering chapters 5, 6, and 7. Here's section 6.3, inverse trigonometric functions, and chapter 7, trigonometric equations and identities. And we're going to look at the first part now. As always, when you take the exam, I can't emphasize this enough. Before starting the exam, please read the following pledge aloud. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam, and so on and so forth. In other words, although the class is online, you're taking the exam as though you're on campus on your own, okay? Now we want to look at inverse trigonometric functions. Recall, only one-to-one functions have inverse functions. And when they do, their composite function is x. F of f inverse of x equals x, as x is in the domain of f inverse. And f inverse OF of x is x, x is in the domain of f. The domain of f of x is the range of f inverse, and the range of f of x is the domain of f inverse. The graph of f of x and f inverse are symmetric about the line y equals x. Also reminding you about the trigonometric functions and various quadrants. Obviously, in the first quadrant, everything is positive. In the second one, sine is positive and therefore cosecant. In the third one, tangent is positive, so therefore cotangent. In the fourth one, cosine is positive, and the inverse, the reciprocal of that, secant. And so having said that, composition of inverse function, f of f inverse equals x and f inverse of equals x. The inverse sine function, remember, none of the trigonometric functions are one-to-one. They don't have an inverse unless you restrict the domain. For example, in order for sine inverse to exist, we are going to restrict the sine from negative power 2 to power 2, and now it becomes a one-to-one function. So y equals sine x. X is between negative to positive infinity, and y is between negative 1 and 1, and it's not a one-to-one function. With the restriction of negative power 2 to power 2, we make it. So we keep the same range. We have to cover the same thing. But we restrict the x between negative and positive power 2. Now this portion only, it's 1, 2. And by definition of an inverse function, when y is sine inverse of x, that means x equals sine y. Domain becomes range, range becomes domain. So the range was from negative 1 to 1. Now the domain is, and in this case, domain was from negative to positive power 2. In this case, the ranges. And you can just see those three important and easy points. Negative power 2, negative 1 becomes negative 1, negative power 2, 0, 0 doesn't change. Power 2, 1 becomes 1, power 2, and you can graph the inverse of a sine function. And in that case, when y equals sine inverse of x, x equals sine y, and x is between negative 1 and 1, and y is between negative power 2 and power 2, f of f inverse is x. Therefore, for sine inverse of sine x to be x, we are concerned with this x, the domain of sine, which has to be between negative and positive power 2. But in this case, this is in the domain of sine inverse, has to be between negative 1 and 1. So this is the concept of inverse trig functions. For example, sine x. So a warm-up example, sine inverse of 1/2. We are interested in finding that. We don't know that. We let it be an arc or an angle, alpha, beta, gamma, theta, your choice. By definition, if y equals sine inverse, then x is sine y. If sine inverse is 1/2 equals theta, then sine theta must be 1/2. And that is a common arc. Theta becomes pi over 6 or 30 degrees. Find the exact value of the expression, justify your answer, no calculator, tan inverse of tan of negative 2 pi over 3. Now, as far as the tangent is concerned, we have the same restriction as sine. The endpoints are not included, meaning y equals tan x. X is between negative and positive infinity. X can be 2 and plus 1 times pi over 2. Y is between negative and positive infinity, and it's not a one-to-one function. The restriction that makes it one-to-one is the same as sign between negative pi over 2 and pi over 2. Of course, the endpoints cannot be included like sign. So y equals tan x, when we restrict the domain between negative and positive pi over 2, range remains unchanged. It becomes a one-to-one function. And y equals tan inverse means x equals tan y. So x is between negative and positive infinity. Y is between negative pi over 2 and pi over 2. So they interchange. And so for tan inverse of tan x to be x, this x must be between negative pi over 2 and pi over 2 belongs to tan x. For tan of tan inverse of x to be x, this x must belong to tan inverse between negative and positive infinity. And so right here, that's what we are dealing with here. And so because this is tan of x, can we go with negative 2 pi over 3? The answer is no, because it's not between negative pi over 2 and pi over 2. Instead, we can figure it out. It's easy to do that because it's negative 2 pi over 3. Okay, so negative 2 pi over 3. That puts you in the third quadrant. In the third quadrant, tangent is positive. This is the same as tan of pi over 3. So pi over 3 is the reference arc. Negative 2 pi over 3 puts us in the third quadrant. So we want tan inverse of tan of pi over 3, which we know it to be square root of 3. And of course, the answer is pi over 3. What about secant inverse of square root of 2? Well, how do we get to secant? Let's go to cosine. So y equals cosine x, same situation, is not a one-to-one function because x goes from negative to positive infinity and it doesn't pass the horizontal line test, not a one-to-one function, and the y is between negative 1 and Here's the restriction between 0 and pi to take care of the business. So y equals cosine x, domain is from 0 to pi. Range covers all the range from negative to positive 1. It's a one-to-one function, and now it has an inverse. Therefore, when y is cosine inverse of x, x is cosine y, domain is negative 1 to 1, and range is 0 to pi. Now, it's important to know how we did the restriction. So as we look at y equals cosine inverse of x, which means x equals cosine y, and the restriction that was mentioned, look at this one. Cosine inverse of cosine of x. This x belongs to cosine, and it has to be between 0 and pi to give you x. Cosine of cosine inverse of x, this x belongs to cosine inverse, must be between negative 1 and 1 to be equal to x. Otherwise, it's not. Now, what about secant inverse? If y is secant inverse, x is secant y, and the restriction is just like cosine, of course, y can't be pi over 2. Remember, we have vertical asymptotes. And absolute value of x is larger than or equal to 1. So I hope everybody's clear on that. So having said that, anytime you want to find secant, first set it equal to alpha, beta, gamma, x, whatever you want. By definition of an inverse function, x equals secant y, that means secant of alpha must be square root of 2. And now we go to cosine because secant is 1 over cosine. So if secant is square root of 2, then cosine is 1 over that. And 1 over square root of 2 or square root of 2 over 2 makes no difference. It's a common arc. Alpha is pi over 4. So that's pretty straightforward. Again, we want to find the exact answer, reminding you of cosine inverse, tan inverse, and so forth. So we have cosine inverse of 1/2. Let it be equal to something, for example, theta. By definition means cosine theta must be 1/2. It's a common arc, theta must be pi over 3. Bear in mind, when we are dealing with inverse function, there's a unique solution. It's different than the equation cosine of theta equals 1/2. That's not the same equation. That has two answers from 0 to 2 pi. So we don't want to mix them up. Tan of cosine inverse of square root of 3 over 2. So understand this is some sort of an angle or arc. So let this be alpha, beta, gamma you choose. By definition, as we just went over that, cosine of beta must be square root of 3 over 2. That's a common arc. Beta must be square root of 3 over 2. Beta must be pi over 6 because cosine beta is square root of 3 over 2. And so we are asking for tan of pi over 6, which is square root of 3 over 3. Let's look at this case, everybody. We are interested in finding cosine of cosine inverse of 1.2. So we are looking at cosine inverse, and cosine inverse, the restriction is that it has to be between -1 and 1. It's not. So it's undefined because 1.2 is larger than 1. Remember, this refers to the range of cosine. Domain of cosine inverse refers to the range of cosine, and cosine is between -1 and 1. So a number that is smaller than -1 or a number that is larger than +1 doesn't work. Also, cotangent, y equals cotangent inverse of x means x equals cotangent y. And x is between negative and positive infinity. The restriction on the cotangent is the same as cosine between 0 and pi. Of course, the endpoints are not included. And for cosecant inverse, we go just like sine, and y can't be 0. So y is between negative pi over 2 and pi over 2. All right, find the exact value of cosine of sine inverse of -1/3, and we're going to do two different ways. And again, I'm reminding you of various quadrants. And remember, when you're looking at inverse trigonometric functions, the answer is unique. So if you let this be some angle theta, then you're looking for cosine theta. So let theta be sine inverse of -1/3. So you're looking for cosine theta. That's the bottom line. Now, because sine is negative, and the restriction we put on sine inverse was for sine to get a sine inverse was to put it between negative and positive pi over 2. Sine in that case is negative in quadrant 4. So in quadrant 4, sine is negative, cosine is positive. Also, sine is y over r. So if we go with y over r, we want to look at it from two different points of view. If we look at it as y, remember, r is always positive. It's either x or y which is negative. So y must be -1 because in the fourth quadrant, y is negative. And so we can calculate the x. How do we do that? Let's look at this. X squared plus y squared equals r squared. Let's just do that. X squared plus y squared equals r squared. So x squared plus y is -1 squared is 3 squared. So x squared plus 1 is 9, x squared is 8, and x is 2 square root of 2. Actually, it's plus minus, but we know x is positive because we are looking at the fourth quadrant. So that's finding out the value of x. I'm going to erase my work. And we know cosine is x over r. So it must be 2 square root of 2 over 3. By the way, we are blowing this up so it becomes clear. This is theta, this is number 3. This has coordinates 2 square root of 2 minus 1. And so this distance is 2 square root of 2. The other way is to go with sine squared plus cosine squared equals 1. So we use identities. Sine squared plus cosine squared is 1. And if that is the case, that means sine is given and cosine is plus minus the square root of 1 minus sine squared. Now, we have to make a decision whether it's positive or negative based on the quadrant. We said it's in quadrant 4. Cosine is positive, so we go with the positive plug in. 1 minus -1/3 to the power of 2. This is 1 over 9. 1 minus that is 8 over 9. 9 comes out as 3. 8 comes out as 2 square root of 2. So pretty straightforward, everybody. All right, we are going to move on. Write the trigonometric expression of sine of tan inverse of u as an algebraic expression. And so we start with the fact that when, and again, just reminding you of what we have seen, for example, Pythagorean identities, where the trigonometric is positive or negative, the concept of a tan inverse. And so this is an arc. So we want sine of something. Let that be alpha, beta, gamma, theta. And if so, by definition, if this is theta, tan of theta becomes u, we want sine of theta. So this is the meaning of this. One more time. Let tan inverse of u be something. Based on definition of an inverse function, tan of theta must be u. What are we looking for? Sine of theta. Well, because tangent is u, cotangent must be the reciprocal 1 over u. And we can use 1 plus cotangent squared equals cosecant squared to get to cosecant, and cosecant gives us the sine. So let's do that. So 1 plus cotangent squared, that means 1 plus 1 over u squared is cosecant squared. We can add these two fractions with the common denominator of u squared. This becomes u squared over u squared. So we have u squared plus 1 over u squared. Cosecant is 1 over sine. So the reciprocal of this would be sine squared, and the reciprocal of this would be u squared over 1 plus u squared. So that's the relationship between sine and cosecant. So sine is plus minus the square root of u squared over 1 plus u squared. Positive or negative, as you know, tangent and sine, they go from negative power 2 to power 2, so they have the same sign. Okay, meaning in the first quadrant, both of them are positive. In the fourth quadrant, both of them are negative. So therefore, there is no need to plus minus. And of course, when you take the root, this comes out, this remains. And again, reminding you, sine and tan have the same sign. They are both positive or negative together as far as this is concerned, okay? The second method, using the triangle, what we can do, we can draw a triangle. Tan of theta is the opposite over the adjacent. So let's say tan of theta is u, or u over 1, the opposite over adjacent. So the opposite is u, and the adjacent is 1. So what is this equal to? 1 squared plus u squared under the radical, or u squared plus 1, either way is fine. And if you want sine theta is the opposite over the hypotenuse, u over the hypotenuse, which is square root of 1 plus u squared. So you can use the triangle, you can use the identities, you can use circles. There are many different ways to come up with the answer. Sum and difference formulas, double angle and half angle formulas. So we start with sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. If you replace the beta with negative, so plus negative beta, cosine of negative beta is the same as cosine beta, but sine of negative beta is minus sine beta. So sine of alpha minus beta becomes sine alpha cosine beta minus cosine alpha sine beta. We have to memorize that. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, and cosine of alpha minus beta, you get it plus in between. Tan of alpha plus beta is tan of alpha plus tan of beta over 1 minus tan alpha tan beta. And if we change this, say plus minus beta, this is tan of minus beta, this is tan of minus beta. This becomes negative, and this becomes negative times negative positive. Therefore, tan of alpha minus beta becomes tan alpha minus tan beta over 1 plus tan alpha tan beta. How do we get to double angle? If I replace this with alpha, I get sine of alpha plus alpha over 2 alpha, because sine alpha cosine alpha plus cosine alpha sine alpha, that means 2 sine alpha cosine alpha. What about cosine? Over here, I'm going to change the beta to alpha. I get cosine alpha cosine beta minus sine alpha cosine alpha cosine alpha minus sine alpha, because we are changing the beta to alpha, which means cosine squared minus sine squared. Now we know Pythagorean identity says sine squared plus cosine squared equals 1, and therefore we can get, if you replace the sine squared with 1 minus cosine squared, we get 2 cosine squared minus 1. And if you replace this one with 1 minus sine squared, you get 1 minus 2 sine squared. And what about the tangent? Over here, if you change this to alpha, you get tan of alpha plus tan of alpha, 2 tan alpha over 1 minus tan squared. So it's very easy to see the transition from here to here. What's even easier is finding cosine squared from here, sine squared from here. So if I want to solve for sine squared, I move this just so you can see what happens here. So if I want to solve for sine squared, I'm going to move this to the right and say 2 sine squared. And I'm going to move this to the minus 2 sine squared to the left and cosine 2 alpha to the right. 1 minus cosine 2 alpha. So if I divide both sides by 2, I get sine squared of alpha. And if I cut this in half, I have to cut this in half. I get sine squared of alpha over 2 is 1 minus cosine alpha over 2. Solve here for cosine squared. Move the negative 1, 1 plus cosine 2 alpha divided by 2. And if you cut the alpha in half, you have to cut the 2 alpha in half. So this becomes alpha over 2. So the half angle. So let me erase my word. And if you want to get to tangent, tangent is sine squared of alpha over cosine squared of alpha. Divide this one by this one to get sine squared of tan squared of alpha. And for half of it, cut this in half, cut this two in half too. And if you want to find sine of alpha, cosine of sine of alpha over 2, cosine of alpha over 2, tan of alpha over 2, it's plus minus the square root. Now, how do you figure out the plus minus? You look at the quadrant and you make a decision. And tan has 2 more ways to calculate. This we covered briefly, so we don't have to worry about that at this point. Now, use the half angle formula to give exact values. Sine of 195 degrees. As you know, 195 degrees is half of 390 degrees. Now, 195 degrees, it's a little bit more than 180 degrees. It's in the third quadrant, and it's important to understand in the third quadrant what happens. First of all, we are going to use this formula, plus minus the square root of 1 minus cosine of alpha, which is 390 divided by 2. But now we're going to emphasize this is quadrant 3. In quadrant 3, sign is negative. That's how you choose the sign based on the quadrant. So negative. Of course, 390 is 360 plus 30, so it's the same as cosine of 30, which is square root of 3 over 2. We can multiply this by 2 over 2. I hope you see the bottom becomes 4, comes out as 2. 2 times 1 is 2, and this one, the denominator goes away, you're done. Negative square root of 2 minus square root of 3 divided by 2. This is the same as cosine of 30 over 2. As you know, cosine of 15 is in the first quadrant. So the formula is this one, plus minus the square root of 1 plus cosine of 30 divided by 2. However, you choose positive because 15 degrees is in the first quadrant and therefore positive. The first quadrant, everything is positive. And cosine 30 is a common arc, square root of 3 over 2. It's very similar to that, multiplied by 2 over 2. And the same thing as this one, except it's a plus sign here. So square root of 2 plus the square root of 3 over 2. I highly recommend you try cosine of 15 equal to cosine of 45 minus 30. Give it a shot as a practice. We want to prove the identities. In this case, secant of 2 theta is secant squared theta over 2 minus secant squared theta. We want to prove that. So we start with one side. Clearly, the right-hand side, RHS, right-hand side is more complicated. Let's start with that. And let's change everything to sine and cosine. Secant is 1 over cosine. So this is 1 over cosine squared. 2 minus 1 over cosine squared. Clearly, we can multiply, this is a complex fraction. We can multiply the top and the bottom by cosine squared theta. When we do that, these two cancel each other. The numerator becomes 1. The bottom becomes 2 cosine squared minus 1. And double angle, I hope you recognize cosine of 2 alpha is 2 cosine squared alpha minus 1. So this is cosine of double angle, cosine of 2 theta, which is secant of 2 theta because it's 1 over that. It's the reciprocal of that. All right, in this case, sine cubed plus cosine cubed over sine theta plus cosine theta must be equal to 1 minus sine theta cosine theta. This is an identity. We want to prove that. What do? We start with one side. Which side? In this case, left-hand side seems to be more complicated. This follows a cubed plus b cubed. So we start with the left-hand side. So a cubed plus b cubed is a plus b times a squared minus ab plus b squared. So this one is sine theta plus cosine theta times sine squared minus sine theta cosine theta plus cosine squared. And the bottom doesn't change. So I hope you see that we are using the identity a cubed plus b cubed. In other words, we factor it. So needs to cancel each other. Not that you have to, you should move this, but I'm going to move it next to sine squared so it becomes clear. This is 1. So 1 minus sine theta cosine theta. And that is the right-hand side, and that's the proof. All right, we want to solve the equation. Sine 3 theta equals 1/2, and we are interested in the first complete revolution from 0 to 2 pi. All right, ignore the 3 theta. Let's say it's x. Sine x is 1/2, and x is either pi over 6 or 5 pi over 6, where x is actually 3 theta. Now, it's a common arc. Remember, sine is positive in the first and second quadrant. This follows the reference arc. Again, I'm reminding you, in the first quadrant, the angle and reference arc are identical. In the second quadrant, okay, reference arc would be pi minus theta. In the third quadrant would be theta minus pi, and in the fourth quadrant would be 2 pi minus theta. That's how you get to the reference arc. And so if this is the case, in order to find the answer, when you have multiple angles, the methodology is to add 2n pi and then divide by the coefficient and then plug in values of n to figure out what they are. So here's what we do. 3 theta is pi over 6. We add 2n pi. Remember, n is an integer. We're going to divide everything by 3 to get theta. When you divide pi over 6 by 3, that means multiply this one by 3. Pi over 18 plus 2n pi over 3. Since this is 3, everybody, we choose n to be 0, 1, 2. For 3 theta equals 5 pi over 6, we do the same thing. We add 2n pi. We're going to divide by 3. That means this becomes 18. This becomes 2n pi over 3. And as I mentioned, we are going to use 0, 1, 2. Why aren't we using 3? Well, let's use 3. If you put 3 here, what happens? This cancels out this one, you get 2 pi. So that means back to really pi over 18, the first one, okay? So that's why you start from 0 and you go all the way to whatever. If this is n, n minus 1. If it's k, k minus 1. And so having said that, as an example, if I put 0, I get pi over 18. If I put 1, I want to make sure that we understand what's going on. So first and foremost, let me change this to 12. n pi over 18. Same thing here, 12 n pi over 18, because this is 18. So if when n is 0, it's pi over 18. When n is 1, we get 12 and 1, 13 pi over 18. When n is 2, 24 and 1, 25 pi over 18. Over here, when n is 0, we get 5 pi over 18. When n is 1, 12 and 5, 17 pi over 18. When n is 2, 24 and 5, 29 pi over 18. So those are the answers. So sine of x equals 1/2 has two answers. Sine of 3 theta would have 3 times 2, 6 answers. Sine of 5 theta would have 5 times 2, 10 answers. Okay. Solve the equation cosine squared minus sine squared plus sine x equals 0, and x is between 0 and 2 pi. Again, reminding you of the reference arcs and Pythagorean identities. Everybody is comfortable with both, I hope, so we can move on. All right. Why Pythagorean identities? We have sine squared and cosine squared. You have to change it, change one of them to the other one. How do you change it? Take a look here. Since we have sine x, we're going to keep this, and this must be changed to 1 minus sine squared. So 1 minus 2 sine squared plus sine x. We want this one to be positive and in descending order. So you can multiply everything by negative or take them to the other side. This becomes positive, this becomes negative, this becomes negative. The reason we do that, so we are ready to do the factoring class. If you have to, you can say this is, let's say, y, and you're dealing with 2y squared minus y minus 1. I don't do that, but I just want to make a point. If we do that, since 2 is a prime number, you have to go with 2y and y. Since this is negative 1, it's just 1 and negative 1. You have to put it in a manner that the middle term works. So if I put a plus 1 here, this is y. If I put minus 1 here, this is negative 2y, and we get the middle one. Or you can go directly to, and replace it, of course, or go directly with the factoring right here. So either this one is 0 or this one is 0. If 2 sine x plus 1 is 0, that means sine x is negative 1/2. If sine x minus 1 is equal to 0, that means sine x must be 1. So negative 1/2, remember, we've already discussed the positive 1/2 for this. So you really have to know the reference arc. So the way this thing is going to work whenever it's negative. Let me just erase first so I can use that space. So this one, if you go with sine x equals 1/2, and in the first quadrant find x, this is x of, or the reference arc, which is pi over 6. So if you want it to be negative, having the same value, okay, that means you're talking about the third quadrant. In the third quadrant, okay, theta would be pi plus theta prime. So add pi. In the fourth quadrant, okay, subtract pi. Okay, subtract pi over 6 from 2 pi. So when sine x is negative 1/2, we have those answers. Sine x equals 1 has only one answer, pi over 2. If by any chance they say solve and they don't give you that, you have to say plus 2n pi, plus 2n pi, plus 2n pi. Okay. Let's prove the identities. Cosine of power 2 plus x equals minus sine x. Let's start with one side. Normally, the more complicated side in this case is side 1. And we need cosine of alpha plus beta. So cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So cosine of power 2 cosine x minus sine power 2 sine x. Cosine of power 2 is 0, sine of power 2 is 1. And of course, this goes to 0. This is negative sine x, and that's the end of the proof. Tan theta over secant theta must be sine theta. We start with one side. In this case, clearly the left-hand side. Tan theta over secant theta is more complicated. And we change everything to sine and cosine. Clearly, this is sine over cosine. This is 1 over cosine. You can just drop the common denominator because they have the same denominator. Or you can say, I'm going to multiply the top by cosine. So this becomes sine. This becomes 1 sine theta over 1. Either way is fine. All right, prove the identities. Cosine to the power of 4 theta minus sine to the power of 4 theta is cosine 2 theta. We start with the left-hand side. And I want to remind you that this is a squared minus b squared, and a squared minus b squared is a plus b, a minus b. So this is cosine squared, squared minus sine squared, squared. So we have cosine squared plus sine squared times cosine squared minus sine squared using this identity. These are conjugates, a plus b and a minus b. Obviously, sine squared and cosine squared, they add up to 1. So you can just ignore it. And cosine squared minus sine squared is the cosine of double angle, cosine of 2 alpha over here, cosine of 2 theta. And that's exactly what we were looking for. Tan x over 1 plus tan squared equals sine x cosine x. Let's start with the left-hand side, and the top is tan x. The bottom, according to Pythagorean identity, 1 plus tan squared is secant squared. Let's change everything to sine and cosine. Tan is sine over cosine, and secant is 1 over cosine. So this is sine over cosine. This is 1 over cosine squared. Let's multiply the top and the bottom by LCD, which is cosine squared. When you multiply these two, you get sine x, cosine x. When you multiply these two, they cancel each other. They give us 1. So these two, the product is just 1. And the top is sine x times cosine x. And you're done. So it's pretty straightforward, everybody. We want to find the exact value, and we notice the sine of double angle, sine of 2 alpha is 2 sine alpha cosine alpha. So this is sine of 2 times power over 8, which is power over 4. What is sine of power over 4? Common arc, square root of 2 over 2. Same thing here. 2 sine of 45 cosine 45 is sine of 2 times 45, which is 90 degrees. What is sine of 90 degrees? 1. Cosine of 7 pi over 12. 7 pi over 12 is the sum of 3 pi and 4 pi over 12. And 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3, both of which are common arcs. And we're going to use cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So cosine of power 4, cosine of power 3, minus sine of power 4, sine of power 3. Pi over 4, cosine and sine, they are both square root of 2 over 2. Cosine of power 3 is 1/2, sine of power 3 is square root of 3 over 2. Replace it. As you can see, the denominator is 4 for both cases. So this is square root of 2. This is minus square root of 6 in the numerator. Square root of 2 minus square root of 6 over 4. Just for the sake of argument, you notice this is a negative value. And 7 pi, 6 pi over 12 is pi over 2. So 7 pi over 12 puts you in the second quadrant where cosine is negative. Cosine of pi over 12, cosine of 5 pi over 12 plus sine of pi over 12, sine of 5 pi over 12. What is that? Well, if you look at the sum formulas, this is cosine of alpha minus beta, which says cosine alpha cosine beta plus sine alpha sine beta plus. So this is cosine of power 2, pi over 12 minus 5 pi over 12. Cosine of alpha minus beta. Pi over 12 minus 5 pi over 12 is negative 4 pi over 12. As you know, cosine is an even function. So cosine of negative theta is the same as cosine of positive theta. So cosine of 4 pi over 12 is cosine of pi over 3, which is 1/2. And now, let's look at cosine of 105, which is cosine of, we want to make up two angles that are common arcs. Just for the sake of argument, you might say 105, they don't work. So they have to be common arcs, 60 and 45, for example. So we are going to use cosine of alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta. So you have cosine 60 cosine 45 minus sine 60 sine 45. Cosine of 60, 1/2. Cosine of 45, like sine of 45, square root of 2 over 2, minus sine of 60, square root of 3 over 2. And so both cases, the denominator is 4. This one is 1 times square root of 2. This is square root of 3 times square root of 2. So square root of 2 minus square root of 6 would be the numerator, everybody. So knowing various identities will help us get to the answer.